Hello. Video masajo. Acceleration to velocity circular motion na ipolutain. To ahi force lambang ibolu na. Betang IPP he luta masajo. Particle khajo circular motion na perform alachun. IPP ta acceleration chu masapena radial pachu hilanga ma. Radial pachu towards the center na. Radial chu AR chalanga ma. AT chu along the tangent. Okay. Abana chu velocity jong chu along the tangent. Atile silai kuna he velo hen betang AT pa he 0 he so AT can be 0. So suppose AT is 0. Okay, imagine you have a uniform circular motion. So if I have AT equals to 0, acceleration khatsu pe remaining to AR na radial path towards the center path. Khutile tang Newton second law pe ha. Acceleration to non zero hi ala chun acceleration o mala chun ipitina ha force umtina chula na. So if I have acceleration towards the center, so that means there is a force towards the center. Betang particle ga straight achi cho na straight achi tin chu tu hin force he chilang kai hin ga push leo chun a path hina achi na path pa hi te bang hidam hilang koi ta chu da he. Okay, so now this is how circular motion is ahung no dan na circular motion ko no dan chu da hi umcha. Only when you apply force F, the path will be circular. Okay, hichi force pa hila do leo chun straight at jang kya chi ta so chu pitinam tele chlai ER rom pa hena hichi pa hi sei ba pang ba chu chi pen hi non zero hi ngai na chu PG ham tele force pa chu. So the force due to this AR, okay, so this force, let's say FC, so this cannot be 0. Hichi A mal chun, so A is due to some force, let's say FC, okay. Chipeni centripetal acceleration iti uchara na. Kutile hichi acceleration kono na force pa chu chipeni centripetal force kiti cho. So Newton second law man fa la chun A chu pha A chu F by M na. Abana batang A chu pha chala A chu A R chu na radial acceleration. Radial acceleration formula chu pita V square divided by R na. R chu radius hiya, V chu speed hiya la chun. AR chu V square divided by R, so this should be equals to F by M. Sila ko na sa force appearing ponam, force should be mv square divided by r. Hichi so this is the force that is responsible for this circular motion. Hichi pa ipiti wa pa centripetal force. Okay, towards the center hiya so centripetal kiti na. Centripetal force mv square by r, and this is always towards the center. Betang circular motion chu tayam za. So if I take a 4 like this, so at point A, B, C la leo na sara A, B, C, D. So at all points, mv square by r is always towards the center. mv square divided by r, mv square divided by r. Hichi pa hi centripetal force. Okay. So this is the force responsible for circular motion. If you remove this force, circular motion pass na, so it will not exist anymore. Example chuchala hi hitia ki rotate jing la he na si force pa hi kala do ala chun hichi ita ki rotate jing pass na nala do chu along the tangent na chi ta so jang ke ya straight line na chi abala chun next chu hichi force ho he na hichi force ho hi hoya ko na hong kon do ham ahung kun na chuna. Example che betang stone khat ailola bob ailola thil khat chuna. So one object here, mass m, let's say hichi mass m hi string to ki attach cho tun hichi pa hi paileo chuna. So I attach a stone with a string and then I just start swirling paileo chun path with the bang de path cho. So the path of the stone will be circular na ita hi ita circular motion o mal chun. So that means there must be a centripetal force. Okay, hichi centripetal force pe ham chala hi. So in this case, it is the tension in the string. String awachu tension umdi chula na chala hi. So here the tension T is the centripetal force. So here the centripetal force. So here the force is centripetal force is tension. Okay, so tension is the centripetal force. Abana example dang so piha. Suppose I have a curved surface na ta hi. Hichi curve is smooth surface dilaw hen na smooth curved surface. Khutila chunga para hi block khat na. Sila hi release boleng ipitire. Hichi block pa yung kisu di chula na. So it will go along this side. Hitai chi ding in den watang so if I draw another sila ya atun ko na bottom most atun ko na diagram hi vilaw hen. Normal pa hi lang force by normal force pa hi. So normal force is like this. Normal force is like this. Sila ko na chu pin observe thaiwa. So you can observe that the normal is always pointing towards the center. Here mabang wat centripetal force kiti sun center lang ako causing ngai chola na. So that means chala hi normal pa hai na. So here in this case normal is the centripetal force. Okay, so the centripetal force is the normal force. Example dang ipin la betheva. Suppose art ne chola na art pa hi avela hi pima moonum chola na avela hi moon pa hi tip itia. So it revolves around the art in a circular path. Moon to circular motion perform alachun, so there must be a centripetal force, right? Which is centripetal force of piham. So it is the interaction between force of gravitational force of attraction between the earth and the moon. Okay, sila gravitation force pahina. So here the gravitation force. So this is the centripetal force. Okay, chi example thuma ko na hiya do thai piham. So centripetal force to circular motion adinga de te ngai na. Ale hi cho centripetal force pa hoya ko na hung kun ham de external factor ko na hung puncha. Okay, external factor na example chala hi tension. Okay. Tension ako na hung kun do ani na pa chu normal ako na hung kun do na. Athum na pa chu gravitational force. Okay. So these are the centripetal force. Okay, hotel abana chu piha centrifugal force kiti chu na chu pi ta le. Agihina chu piham centripetal to. Example chu awa stone kala pa chu na. Stone hilayam za sung kha chu so with a string it is attached, now it is rotated. Okay. Itia no rotate wala chun a path pa hebel chun thai circular path chu na chi. Ale velocity hoilanga chia. So here the velocity is towards this. Okay, this is v. A motion hi veleu chun a motion hi bedang. Hita hi xy ka zia la chun. Motion hi hoilanga ma along the y direction na chi chu na horizontal plane na i vera la chun. V pa hi stone pa hi song pa hi y langa chi chu na a hi wanga chu betang i hian ma bangwa chu chai tension chelanga hi centripetal force cho. Okay, khutile hi mass pa hi na hi object pa hi chelanga la chi lo a chi na chu chelang ni chu na. So that means along the x-axis, if there is no net movement along the x-axis, the net force on the axis must be zero na. X direction lang net movement am lo ala chun net force to zero hi ngai chala. Butang chelang force butang hi object pa vela chun chelang y hi za chelang x la wala chun x langa hi object pa motion chila jong chilo a chin chu hoilang ha hi tai jang ke ha chi na. So that means the net force along the x-axis should be zero. Okay, ai wanga chu chala hi vela chun hi force kha bo se am chala na chi hita hi block khat kania tang block khat kania chilang block pa chu chilang 10 newton ka kaya la chun huilang chi ha block chu left lang ke tol chula na chilang hi movement om ngai cho ai wanga chilang hi fc khat bo se nei wa ai wanga bola hilang chi lo ha na he chi object pai bola na chi lo ham. So now hi chi motion if hi ground frame pa event chula na tula pa event vai le chun hilang tension ma object chu chilang chi cho. So now imagine yourself as this mass. Okay, so now you have to take this stone as the frame of reference. So take the object as frame of reference. Object parts of frame of reference la chun hisu pikase na ha tang relative I bol taw chala til kha frame of reference chu. So you have to sit there and observe the motion. Okay, if you sit on this stone and observe the whole motion with respect to you, so that stone hi object pa hai na. So this object is at rest with respect to you. Aji chu nang achunga na to ja so nang stone pa chevela chun chang lo chula na. So with respect to you. Okay, aba na chu stone pa hai na object pa hai hi pa hai frame of reference la wala chun hi inertial frame hi dam hi non inertial frame hi dam. But hi stone pa hai chun acceleration chula na chalang towards the center. So you have AR. Acceleration o ma la chun tang frame of reference pa chun non inertial frame kiti cho. So here you can see that when you take the object which is performing uniform circular motion as the frame of reference, so that object is a non-inertial frame. Okay, one thing. So that means you cannot apply Newton's law in that frame na. Hilai fx equals to 0 hon apply thilo chu. So there is a condition. Okay, you can apply Newton's law in a non-inertial frame. Non-inertial frame achu ihon rule here to piha Newton's law ki apply thilo chula na. But you can apply a Newton's law in a non-inertial frame. So if you include a pseudo force. Okay, he chela he batang achung hen tawleo chun So what will you feel? You will feel that you are being pushed away in this direction. Garia to ho chla na garia to phal khun lampi ko yang chi phal khun batang garia to ho chu pitizia hilang kai he thikan an son ve ta na your body will be pushed towards. So if the circle the curve is like this, if you'll be pushed outward away. So this push is not a real force, okay? It is an imaginary force. So this is what we call pseudo force, okay? So chila hi object by frame of reference and allow vala chun hi object chunga chu. So the object will feel a push outwards. Let's say this is F dash, okay? So this force is a pseudo force, okay? In a non-inertial frame chunga chu na pseudo force na ha be vala chun. So after adding pseudo force, now you can apply Newton's law, okay? To Newton's law apply lo chun isai ma bang wa chun along the x-axis force 0 chula na movement ima cham lo chula khutele pi ha. So minus Fc equals to F dash ga tiu te. So that means what is F dash? F minus Fc plus F dash equals to 0. Khutele F dash chu pi ha Fc chula na ki bang chat. So these two are equal and opposite. Okay, so F dash is equals to Fc. Khutele Fc chupita mv square divided by r tiu chula na centripetal force chu. So that means you also have this F dash is equals to mv square divided by r. So this F dash chila pseudo force pi na. So this pseudo force, if you see, it is exactly equals to the centripetal force. Masapena chu ki bang chat na pseudo force pa jong hi mv square by r is a centripetal force jong chu mv square by r na. Abana it is opposite to the centripetal force. It gets cancelled out with the centripetal force. Okay, so this pseudo force is called centrifugal force. It is pseudo force pa hai na. It is pa hi centrifugal force. Okay, centripetal force pa to hin centrifugal pa hai na. Aki hi na hon pi ha. Betang hi ti pa la hongom ni ha. So this pseudo force you will feel, okay, you can only feel pseudo force. You cannot see it. Okay, hiti pa na feel diu ha. Object ng na to va na. Object ng na to va la chun only then you will feel. Okay, so that means so this centrifugal force is valid. Okay, valid only if you take the object as a frame of reference. Okay, remember that point. So the centrifugal force will exist only if you take the body as a frame of reference. Okay. So if you look it from an inertial frame, to ground upon another okay, so this is 0. So with respect to ground, there is no centrifugal force. Okay, you have only centripetal force. Right? So that is the most significant difference. Okay. Atile ihed the hochu piha centrifugal force ki ticho masapena chu object pa chu na. Object pa chu frame of reference frame aila dio. Okay, object frame pa chu na. Reference frame aila dio. So this reference frame is a non-inertial frame. Okay, non-inertial. So japan here. Abana chu piha. So this is always outwards. It is a pseudo force, it is an outward. Okay. Abana he japan here. So this is exactly equals to the centripetal force. Centripetal force mv square by r na. Abana f zangsu. So this is also mv square by r. Okay. So now let's try to summarize. Okay, what we have learned. So the radial acceleration v square by r is towards the center. So according to Newton's second law, acceleration of malachun. So there must be some force acting along this acceleration, which is producing that acceleration. Okay, towards the center. Na Newton's second law na apply malachun as well is ima bangwachu. So if chujang po mv square by r podding ahilole see, you know v equals to omega into r na. You put this value here, you'll get omega square r. Okay. Omega square r zong ke bang zibeta. For mv square by r force pa hai na. So this is directed towards the center, always towards the center. Chizi achu centripetal force ki tichu na. So this force is needed. Okay, it is a mass force. It is needed to keep the particle in a circular motion. Abana zo example tum ka p bang wachu. So this force must originate from external sources. Gravity ham na, tension ham, electrostatic force etc. Okay, so friction force okay, so there are many other things, right? And what about centrifugal force? So Newton's law are valid only in a non-inertial frame. Hichi a law chu jana theory pa chu. So Newton's law chu inertial frame both are valid chu na. So here the Newton's law are valid in a non-inertial frame only if there is a pseudo force. Okay, kasi banga chu na pseudo force of malabo non-inertial frame acho Newton's law ki apply thedi. Okay. A body undergoing a circular motion is moving with respect to the ground frame to inertial frame na. But if the body is taken as a reference frame, the body circular motion perform pacho na his pacho frame of reference anala awala chun. So with respect to you, so if you sit on the body will be at rest. Okay, so it will be at rest. Net force on the body is 0. Okay, so if the body is at rest, that means net force is 0 ay ngay na. So the rotating body is a non-inertial frame as ito acceleration om azo kasi mga cho. So to make net force 0 hinading aso there must be a pseudo force in the opposite direction. So in opposite to the centripetal force. Okay, so which will cancels out the centripetal force. It's a pseudo force part of PKTM, so that is called a centrifugal force. Okay, centrifugal force 2 radially outward hingay. So it has the same magnitude as centripetal force, which is mv squared by r or m omega squared r. So remember, centrifugal force is valid. Okay, centrifugal force is valid only if we are observing the motion with respect to the rotating frame. Body only then you will feel the mv squared by r. Okay, centrifugal force. So centrifugal force acts because we describe the particle from a rotating frame, which is a non-inertial and still uses Newton's law. Okay. Pseudo force of just Newton's law ki apply na non-inertial hi wanga. Okay, so that much theory. Let's apply some examples here. Suppose example I have suppose I have a block na. Block hi 2 kg la leo 2 kg by string to get so now it is rotating about this axis. Okay, keep pay na, so you are swirling. So like this, omega is given as 2 radian per second. For example, question to calculate the tension. Okay, calculate tension in the string. 2 kg pa question solve the palachun kasi so you have to sit on 2 kg and then solve it. Okay, so 2 kg free body diagram ko draw lechun sila nga tension dium na sila tension chu wire tension dium ding hotele sila nga pm ha. So you will have mv square r by m omega square r na. Tension string per length 1 meter la lechun. So on the right side you will have centrifugal force. So this side you have T, tension force, which is the centripetal force. So here you apply net force 0. As you should then swirl value a path here bitaw ha. So it is like this na. So it is going towards V is along the side. Okay. So along the X, see if I take X, if I take Y, along the X there is no net motion. So Fx equals to 0. Right? Fx 0 net force 0 they cancel each other. Okay, so force equation 0 na direct asong tai T equals to m omega square r mass of 2 omega of 2 square into radius to 1. So this is how much? 8 Newton. Similarly, I can take a block suppose I have 2 blocks. Okay, like this. Khatsu 2 kg is khatsu 3 kg. Okay, length to 1 meter, 1 meter. Yeah. So with the same omega, 2 radian per second. Okay, calculate tension. Tension ki banglaw da tayo. Chalai T1 umding, chalai T2 umde. Okay, so calculate T1 and T2. Right, so how do you do? Same thing. Masapening utang itay block system ang kipi pala chun aning pempenahin panlaw chun. 3 kg pa ko FBD ka zila chun tabang dia. So FBD 3 kg. So vai lang aso tension T2 ma zila nga so pide ha. So if they are rotating in a circle, you'll have m omega squared outwards. So m omega square r. Okay. So net force 0 na along the y net force 0 is aso. So these two will be equal. T2 equals to m omega square r. Value po lang sa dia. So m is 3 omega to 2 square into radius to 2 kg pa hai. It's a block pa thickness pa hai na negligible la leusen. Okay. So that means you have 1 meter, you have 1 meter. So total is 2 meter. So you put 2. So finally how much? 2 2 are 4, 4 2 are 8, 8 are 24 Newton. Okay, T2 is 24 Newton. Abana chita pang acho 2 kg jong ho free body diagram ka zilo chun 2 kg. So on the right side I have T2, on the left side I have T1. So additional 2 kg jong circular motion performed so na. So that means I will also have here m omega square r. Okay. Hotile along the x-axis net force 0 hila chun chito hin chi ke bangchat. So you can equate them directly. So T1, okay, T1 equals to T2 plus M omega square R. T2 chuzar ham 24, M chuzar ham 2 omega to 2 square into radius to 1 na 2 kg per radius hivetang. So this is 1. So if you solve this, how much will you have? 24 plus 2 2 or 4 4 2 are 8. So this is 32 Newton. Okay. Okay, question and solve pangit tauten masapena chu. A particle of mass m is observed from an inertial frame of reference. Okay, so inertial frame of reference. Hechichoki observed na. It is moving in a circle of radius r, uniform speed v. So the centrifugal force is ground inertial frame ground on the. Suppose you are standing on the ground and looking at the particle. So the particle is mass m. It is moving with speed v. So radius r. Atila chila hi centrifugal force na ground upon na valation is that. So I have explained this already. Okay, centrifugal force ke tichu non-inertial frame na objects go to palable. Only when you observe from here you will feel that mv square by r. Okay, that centrifugal force. If you stand from the ground and look at that, so there will be no centrifugal force. Okay, no centrifugal force from an inertial frame of reference. Until answer is ham. So this would be 0. Okay, but if you sit on m, you will have mv square by r outwards. Okay, you have to understand the difference. And in a stone of mass m is tied to a string of length L. Example stone. So this stone, so tied to a string length L. Until a stone path stone path. So the path will be like this. Okay, circular path na. Abana velocity towards the tangent v is a string pa. So if the string breaks, so the stone will go towards the velocity. Okay, along the straight line. So this would go along the tangent. Okay, question 3 na. A vehicle of mass 200 kg, okay, mass is given, is moving a level curve road 70 meter. So angular velocity omega to 0.2 radian per second. So total centripetal force na question chun. But an car hi value chun si banking of road ajung bol diuja. Ita hi circular path chi ala chun. Tang hita circular path ta bang. So it is like this. Okay. Hi top view na. Chunga pa ni value chun chi car chu chi hi. Top view abana che pa hi back view. Back view anu apa value chun na. Anu apa na value chun car tire to lampi ki ka happy ma friction na lampi to so friction is always it is along this side. Okay, car path value chun because of the pseudo force it will be pushed away. So prevent the thing as a friction to na. In this case the friction is the what? Centripetal force. Okay. Atile car to kaya hi mv m omega square r ding. Friction to na atile car to motion to hilanga. So it is along this side. So that means net force is 0 on this side, x side. Hichi friction force pa to hinchi pa ki bangsa dinai. Okay, as you motion to na hilanga hi x langa hi motion umlau. Okay, you just equated. So the centripetal force is the friction force, so which is equals to m omega square r. Mass to 200, omega to 0.2 square. Radius to 70 meter. Okay, so 200 into 0.04 na 0.2 square, so 0.04 so I can write 4 divided by 100 into 70. So 0 0 cancel. 4 2 are 8 8 7 are 56. 560 Newton. Okay, so answer is 560 Newton. Okay, question 4. Japan medical exam question. 2024 kuma. A bob is whirled in a horizontal circle by means of a string. Bob na so this is a bob. String to connect and then okay. So now it is rotated like this. Question initial angular speed. Okay, atila chu omega 1 initials omega I tila. So this is 10 rpm. So rpm pa held out I think the revolution per minute. If the tension in the string is quadrupled, let's say tension is T. Okay, so in the second case, you're going to increase the tension by how many times? By 4 times. Okay, quadrupled. Atila chila hi omega hi zat itadem. So that is the question. Okay, the new speed will be. Batang first case ahi body hi value chun. Chilanga hi tension uma hilanga hi m omega square r dina. Abana second case ahi value chun velanga hi 4 t ding zilanga hi m omega square r mam kidina. Evan chila hi omega pa hi final hongiding chimasanga ba chu initial hongide. Okay, so first equation chupi ha t should be equals to m omega initial square into r. Okay, equation 1. Second na chu 4t should be equals to m omega final square into r. Okay, so then divide bola na divide bola zat ham. So t divided by 4t. So m into omega initial square r divided by m into omega final square into r. Okay, cancel cancel na tt mm rr remaining chupi ha 1 by 4 equals to omega initial square divided by omega initial divided by omega final then square using was square na atile sila omega final square is adding ham. So 4 into omega initial the whole square sila para hi omega final chupi ha rule alojun. So 2 into omega initial, right? So 2 into omega initial is 10. So this is 20. Okay, rpm. So your answer is 20. Okay, Abana question 5. If the radius of curvature of a path of two particles of the same mass, okay, same mass to m1 equals to m2. Particle niyam chala na 1 to 2 tilaw ratio of radius to na radius of curvature. So r1 by r2 to kpm. So 3 by 4. In order to have a constant centripetal force, so chala same centripetal force on it na. So velocity, so v1 by v2 to ham. That is the question. Okay, velocity will be in the ratio of what? So let's say the centripetal force for the first one is m1 into v1 square divided by r1. Abana anina pa chu m into v2 into square divided by r2 until f1 by f2. F1 to f2 chu kibang na cho. So if they are equal, so m1 v1 square divided by r1 equals to m2 v2 square, so divided by r2. Sila para ehon p deu ham ehon v1 square by v2 by v2 deu jala na. So m1 divided by m2 or m2 divided by m1 into r1 divided by r2. Value put down le m1 to m2 chu kibang na. r1 by r2 chu jat ham 3 by 4. Okay, atila v1 by v2 square to 3 by 4 helechun. So v1 by v2 whole square is equals to 3 by 4. Tile v1 by v2 to zat ham v1 by v2 to root 3 divided by 2. Okay, so ratio will be root 3 is to 2. Next, a car is moving with constant velocity of 20 meter per second in a circular track. Speed kipi na. So v is given as 20 meter per second. Radius to zat kpm, radius to 40 meter. A bob is suspended in the roof of a car by massless string. So roof apara chu bob khat. Pendulum na mukha jala na pendulum tabang ako tai ki khai cho. So the angle made by the string with the vertical will be wetang lampi ko yan chi pha lehun. So lampi ko yan chi pha lehun, your body is thrown outward. Okay, so similarly hechi string pa jong hechi bob ki khai pa jong hena lam ko yan pa pha lehun. So now it will get tilted like this. So this bob, if you sit on the bob and look at the bob, silang ay tension t na. Silang ay force mv square by rt pa jun akay da silang. Okay, so now it is experiencing a pseudo force, so which is why hechi bob pa hai na silang hai. So now it is shifted towards the right. Atila chalai angle pa hi theta la leuhen. Chipai theta la leuhen. Hechi pa jong hi theta hi ngai na. So that means this is theta. So I can split t into two components. So one is t cos theta, another one is t sin theta. Adang force beam na layam mg jong na lay na. Mg chu downwards. T free body diagram. So question jun angle ado na hatile fx watang hechi hi car hechi langa chi so ai wanga bob hi vertical like high so na a motion chu hirang ha motion chu. So motion is along this direction. Okay, so here I can say motion is into the page. Hechi gari chu here gari chu. So it is 3D. You have to try to imagine. Okay, examples gari chu time so Nah, so it is going along that side. Okay, that means on the right, the left, the net force should be 0. Okay, so fx equals to 0, fy equals to 0 bolle chuna chalai. First betang net force 0 hele chun chi to hin chi ki bang chat. Okay, vertical net force 0 hele chun chi to hin chi ki bang chat. Okay, as it's direction of motion chu along the vertical chalang hi cho. Okay, silang hina tu he xyz bolle hen to hi betang he chi y a hi na hi chi pen hi x a hi le chun motion chu z axis langa chi cho into the page and outward hita z axis langa. So this is the v motion. So that means along the x and y net force is 0. Atila directly I can write, so t sine theta should be equals to mv square divided by r, and t cos theta should be equals to mz. Okay, so equation 1, equation 2. Let's say divide ga bolle chun janong pod diha. So t sine theta divided by t cos theta should be equals to mv square by r divided by mz. Okay, so cancel theta cancel out chun. So t cancel out, cancel out. So sine by cos chupita 10 theta equals to, so v square divided by rz, value put vala 2 in, so v square to 20 into 20, so divided by radius to kpm 40 kp na, z to 10 la leuchen. So I have 2 2 or 4, I have now equals to 1. So that means 10 theta equals to 1. Theta is at the so theta equals to 10 inverse 1. So 10 is at 1 ha, 45 degree. Okay, pi by 4 is 1. So answer is C. So next question, 3 cars A, B, C are moving at the same speed on 3 bridges. So lay na bridge thumum cho. Sila chu itabang bang ha lay ho chu car A goes on a plain bridge. Car A chu bridge achina pa chu jangke na car A chu. Okay, let's draw a car A here. So car A is going on a flat surface. Car B chu on a convex upward. Convex upward. Convex side is upward. Na. So tila chala hi car chipen ha. So car B na jipa hai. So this is car B. Car C chu concave upward. Chila hi car B om na la hai. Okay, question chu pita. So F A to F B to F C chu normal forces exerted by the cars on the bridges. So when they are at the middle of the bridge, normal force contact force to normal na. So here you'll have normal exerted by the ground on the car and normal exerted by the car on the ground. So these two are equal. Okay, this is FA, right? Atila car pa hai na. So you take this car as your frame of reference. Car here frame of reference la force of ppm. So you will feel the normal from the ground. So normal A. So weight of the car to downwards. Okay, so mz. Weight to kibang so na 3 identical cars ke cho w tiu ta weight cho until the force dang ma cham lo na plane na pa he b pa ho vela chun same thing. So normal is upwards, normal on b, so weight is downwards. Okay, aki hin cho pe to bi circular path ta che. Okay, so when you're going in a circular path like this, so you'll experience an centrifugal force outward direction, right? So in this direction. So here I'm going to write in our direction I will experience so centrifugal force FC, all right. Okay, abana C na hi velo chun C na hi normal to upwards, weight to downwards, to a circular path hi velo chun hita jala na si. So you will experience centrifugal force in downward direction. Okay, outward from the circle. So that means centrifugal force is downwards. Atila motion hi velo chun chilang hi jala na. So it is towards the x, towards the y net force is 0. Okay, motion velocity chu chilang am na. So velocity is along this side, so along the y net force is 0. That means NA is what? W. So FC plus NB should be equals to W. Or I can say NB equals to W minus FC. Now tumna pa ho NC should be equals to FC plus W. W plus FC, right? Atila compare boletion to hin NA chu piha W bo se na NB chu W la akuna thirkha ke minus do lesun. So that means NB is smaller than NA. Okay, atum na pa chu W was thirkha na ha bewa lesun. So now NC is more. Okay, relation chu piha NC pa chu tam pending abana chu N yang miding athumna chu NB pa chu hom pending na aji chu W akuna themkhat thilkhat na minus do ji wa chu. So that means NC that means the FC has the greatest, okay, maximum normal forces, right? So answer is FC. Okay, last question. It's here from a classic question. To normally ball pouch na chala in apply to. So a track consists of two circular path ABC. Chu helai ha chala ABC pa he. Abana chu CDE. So this part, okay, convex upward and concave upward. Radius chu 100 kp na. Joined smoothly as shown in the figure. Its part subtend right angle. HO election question with a question by A, B, C, CD sub question lium. So I have no basic nothing as a relevant purpose as you can say that. So here it's part okay, a cycle weighing of 100 kg together with the rider. Total weight to total mass to 100 kg. Travels at a constant speed of 18 meter per second, 18 kilometer per hour. So 18 kilometer per hour achu. So if you multiply by 5 by 18, so I will have here 5 meter per second. Kinematics I bolzi ho chale na. Kilometer per hour kepi alachun meter per second chu confine adding achu 5 by 18 to multiply bol ngai. Okay. So find the normal force contact force at B and D. Masa pen B bolo na. B ko value chun. So it is like this. So object within gazing kate cycle pa na atila cycle pa weight he downwards weight is at 100 kg le 100 into 10 newton downwards abana chu normal force chu let's say NB question chu normal force ado na atila path he value circular path chula. So that means centrifugal force outward direction. Okay, so this is mv square divided by r. Atile motion chu along the x axis chu along the y axis net force 0. So that means NB plus mv square by r should be equals to weight. That means 1000. NB chu zadingham 1000 minus mv square by r value pula chun m chu 100 v square 5 square divided by r chu zadham radius chung chu 100 na 100 cancel out. So 1000 minus 25 is that 975 Newton. Okay, normal at B. Abana chu normal at D na hu. So now you have concave upward. Okay, let's say the cyclist is here. A weight pa chu 100 into 10 Newton downward. Normal pa chu upwards. Normal at D. To a circular part evaluation hi time na. So centrifugal force should be away from the center. So that means downward I have mv square divided by r. Okay. So vertical as a net force 0 helachun ND should be equals to 1000 plus mv square divided by r. So 1000 plus mass to 100 5 square divided by 100. So 100 cancel out. So I will have 1025 Newton. Okay. So normal force centripetal force calculate na kabo says na basic head na ding acho. Okay, so if you want to solve further B part, C part, D part na solve no vala achiever ma na an evaluation question. So I think that much is enough. Okay, here's an bolt out in centrifugal force to centripetal force chung sanga na. Abana hi video khari bol be deu hintin banking of roads bol deu. Oh abana ko. So one more video on circular motion. Okay, so we'll stop here. I hope you understand. So I'll see you in the next video. Thank you.